Hello everyone. In this video, let's discuss how to write a program to find number of 1 bits in a given integer. Write a function that takes a binary representation of an unsigned integer and returns the number of 1 bits it has, that is known as the Hamming weight. Let's take an example and try to discuss about this particular question. For example, if I give my input value as 9, so that should be an integer value. So if I give an input value as 9, we have to convert this number into binary number. So the binary value of 9 is 1001. In the binary representation of 9, how many bits has the value as 1 that should be printed? I mean, count of 1 should be printed. In this case, the output should be 2. This is a question. So the logic is very simple. What I can do is, I can perform a right shift operation for each and every bits until the input value n becomes 0. When you are performing right shift operation, if we have 1, you can print the value, count value as, you can increment the count value as 1. So in this case, what I can do is, I can take 1001, I have to perform AND operation with 1. When I perform AND operation with 1, what is the answer I will be getting? I will be getting my answer as 1. So when we are getting the answer as 1, increment the count value and then perform right shift operation. So when I perform right shift operation, the input value n becomes like this. So what is meant by right shift operation? The rightmost bit will be removed, all the bits will be moved rightwards by one time. Then again perform AND operation with 1. So here I have got the value as 0. So count value should not be incremented. Then again perform right shift operation for the value n. So when I perform right shift operation for the value n, it becomes 0010. So perform AND operation with 1. So when I perform AND operation with 1, I'll get my value as 0. So whenever you're getting value as 0, count value should not be incremented. Then again perform right shift operation by 1. So input value n becomes 0001. Perform AND operation with 1. I've got my output value as 1. So whenever we're getting output value as 1, increment the count value. So for this case and this case, we have got 1. So count value will be incremented by 2 times. Then again perform right shift operation. So when I perform right shift operation, the input value n becomes 0. So whenever the input value n becomes 0, I should stop this condition. So this is one logic. But in this case, how many iterations happening? The iteration is 4 times. So based on the most significant bit. So here the most significant bit is 1. So it has to iterate 4 times. There is one more efficient logic which will iterate based on the number of ones present in the given binary representation of an integer. Let's discuss about that logic. So let's take the same input value n as 9. So the binary representation is 1001. In this case, we will not convert the number into binary at all. Instead of converting the number into binary, we will be performing bitwise operation. So everything will be dealt in bits. So the logic is very simple. Perform AND operation for n and n minus 1. So what is the n value? N value is 1001. What is n minus 1 value? N value is 9. N minus 1 is 8. So perform AND operation for n and n minus 1. So when I perform AND operation, the value becomes like this. Okay. How many times you are performing this operation, that many times you have to increment the count value. That's all. So one time I have performed. Again repeat the loop. That what is my current n value? My current n value is 8. Perform AND operation with n minus 1. When n value is 8, n minus 1 value is 7. Okay. Perform AND operation, I will get my value is 0. So until the input value n becomes 0, you have to repeat this process. So here the n value becomes 0. How many times the loop has been iterated? 2 times the loop has been iterated. So the output is 2. This is the efficient logic. This is nothing but an algorithm called Brain-Cunningham algorithm to find the number of ones in a given integer value, or you can say count of set bits, or you can say number of 1 bits in a given integer without converting into binary. We can solve this. So this is the efficient logic. So the logic is very simple. You have to take a while loop and you have to give the condition saying that input value n should not be equal to 0. If it is not equal to 0, what I will be doing? I will be performing AND operation for n and n minus 1. So in this case, what happened? The value n will be changed. Then increment the count value. That's all. This is the logic. Until the input value n becomes 0, we have to iterate the loop again and again. Now let's try to implement this program. So here they have given n, and people might get confused saying that here n they have given binary representation. Actually they have passed the value of n as an integer, not the binary representation of this value. Okay, so here they have passed the value of n as 11. So the value of n is 11, not this value. For our understanding, they have given the binary representation of 11. Okay, so they have passed the value n as an integer value called 11. So let's try the logic here. I'll be taking a variable called count. I'll give the value as 0 because we need to find total number of 1 bits present in the given integer value. So let's take a loop, n not equal to 0. What I have to do, I have to update value of n as n and n minus 1. Increment the count value. Finally, return the count value. That's all. This is the logic of the program. Let's run the code now. It passes the test cases. Let's submit the code. It passes all the cases. That's all.